Hi there, Fix-It Scotty here, and if you've been following my channel, you know that I've been restoring this 1978 Volkswagen Bus. But not only that, I'm also working on converting it into an electric vehicle. Now I've been testing my wiring, my EV wiring, with this old battery that came out of my son's Honda Civic, but it's been getting so weak that I recently had to replace it too to continue with the wiring and testing. At the same time, I was also been recently watching a channel that I subscribe to called FunForLouis. Now, Louis' channel focuses around travel and sustainable living, but I highly recommend you check it out because one of the other things he did on his channel was he converted a mid-70s Volkswagen Bus to an electric vehicle. Also recently, he filmed a series of videos where he took his electric Volkswagen van and he drove it across country from California to New York. Now during that road trip, I expected him to have issues, both with like range anxiety, charging availability, and things like that. But I was struck by the fact that he had multiple issues with his 12-volt battery. So I decided to make this video to talk about battery options for an EV conversion, but also analyze what happened during Louis' road trip with his 12-volt battery and see if we can mitigate that so that it doesn't happen to us. So stay tuned. If you go to my channel page on the playlist, there is a playlist just for this EV conversion of this Volkswagen Bus. You can see I'm missing one major thing, which is the motor and transmission back here. So the two big projects I have left to do are the motor and transmission and the battery pack. Yes, those are two big major projects, but I got a lot of the EV conversion projects, the more minor projects done. And one of those projects was to replace the 12-volt battery. Like I said, I could no longer test with that other one. It was getting so weak. In this case, I just went to my local tractor supply store and I bought a standard car starting battery that just fits in the car. So this battery would work whether I had a gas engine or whether I was an electric vehicle. Now, similar to Louis' build, I'm also going to build out a 144-volt high voltage pack for my motor and controller setup. Now, despite the fact that I'm going to use a different motor controller and DC to DC converter components that Louis has, the similarities are I'll have the same voltage pack and I'll have a similar situation to how we deal with the DC to DC converter, in that when I turn the key switch on in my car, this battery will provide 12 volts to the controller and to a relay inside of that contactor box. That relay will turn on or enable the DC to DC converter, such that, like an alternator, that takes over the 12-volt duties of the car. And at the same time, the controller will get that 12 volts, which will allow it to pull in the contactor to get the high voltage from the battery pack into the controller ready to apply to the motor. And Louis is a similar situation. So you turn the key on, the DC to DC converter takes over the 12-volt duties. You turn the key off, the 12-volt duties go back to the accessory battery. Now, let's watch a clip on day 2, the evening of day 2, where he had a complete power failure of the car. And let's talk about why that happened.
Miles ago. Why have I lost power? That doesn't make any sense. Wow, I thought I'd allowed plenty of time. I did an hour and a half extra charge. Right. Could be the 12-volt battery. I've managed to plug in my little battery charger. I think for some reason the 12-volt wasn't charging. Maybe I killed it because I was trying to run the inverter off it, but it looks like... Surely this is going to work now. Yes.
My first thought when I saw he lost power was to blame the battery management system. But no BMS would be configured to cut the power completely off on the motor without any warning. That would be incredibly dangerous. So my theory now is the loss of power was due to voltage sagging. People that know EVs know what I'm talking about when I'm talking about voltage sagging, but for those of you who don't, let me just really quickly give you a visual for this. Voltage sagging, if you think about pulling high current from a battery, it's like, think about a battery and voltage sagging as being like a spring, right? The more current you pull from the batteries represents the harder you pull on a spring. And the more stretching the spring does represents the voltage sagging or the lowering of the voltage. Think about a new battery or a battery at the top of its state of charge. Like for example, Louis' 144 volt nominal battery, fully charged is probably a little over 150 volts with a full state of charge. Full state of charge is almost like having a brand new tight spring, right? The more current you pull from the battery, it does cause the string to stretch, but it doesn't stretch very much. And then when you stop pulling current from the battery, it returns basically to the same position it was before. So this is very similar to a full state of charge, where when you step on the throttle, yeah, you'll reduce your voltage initially by a few volts, but after you let off the throttle, it'll come right back up to where it was before. A lower state of charge on your battery is like having a stretched out spring, and that the same amount of current you apply to it will actually cause it to stretch harder. And then therefore the voltage will sag much more and much more pronounced with the same amount of current you're trying to pull out of the battery. And similarly, when you let off the throttle and the spring goes back to normal, it won't go back to its original. So in terms of the battery, in a lower state of charge, the battery at rest will never get back up to that 150 volts that it was when it was full. It might only get back up to 135 volts at a real low state of charge. Now that evening when Louis was driving, his state of charge was about 10%, as you can see on the video. So his battery looked more like this. And because he's driving at night with all the lights on, in a car that has the aerodynamics of a brick, and with that low state of charge, his voltage sagging was probably not like this. It was probably like this, just a sustained hard pull, because he's driving on the highway and with all, like I said, with all his lights on and everything. So it got a sustained voltage sag. What I believe happened was his voltage sag caused his DC to DC converter to drop out of the circuit. Why is that? Well, like any electronic device, the DC to DC converter has an input range. On mine, it's between 132 and 168 volts, which makes it ideal for that nominal 144 volt pack. Because at a full charge, like I said, it's in the 150s, and at a real low state of charge, it may be in the mid 130s. Either way, that DC to DC converter should be able to stay online. But in Louis's case, he was pushing it super hard, and I believe what happened was the DC to DC converter got underneath its minimum voltage range and completely dropped out of the circuit. In which case, his accessory battery should have taken over the 12 volt duties. But unfortunately, in Louis's case, his 12 volt battery was dead too. He had a double whammy. So he had completely no 12 volt system at the time, and therefore his contactor let go and opened up. That's what I believe caused him to suddenly lose all power to the motor. Also notice that by the end of that clip, he said he got it to turn back on again. Why is that? Well, because he had a jump pack, and what he said was he put his jump pack or his battery charger back onto his battery terminals, and he was able to get the car to turn on again. What happened was that jump pack was able to hold the contactor back closed and operate his lights and other accessories for enough time that it took him to get a few more miles down the road and to his destination that night. So let's check out what he said the next day.
Another problem. My 12 volt battery died last night, and I thought that if I charged it last night that everything would be okay, but I think it's completely dead. That actually stopped the main charging of the main batteries. So it looks like until I go and replace the 12 volt battery, the main batteries aren't going to charge. So they stopped probably after a couple of hours last night.
So notice that the next morning when Louis said his battery is dead and he was unable to charge his car, why is it that he couldn't charge the main battery pack just because his 12 volt accessory battery was dead? Well, the reason is this. A little bit of a primer here. This is a J1772 gun, similar to what he was going to use, an EV charger, and it's got 5 pins in it. 2 of these are power pins and one's a ground, and then these 2 are signaling pins. Now notice if I stick my finger in here, I won't get shocked. This could be 220 volts at 30 amps, this particular gun. This should shock me, but it's not going to shock me. Why is that? Well, it's because these 2 pins, one of them is called a proximity pin, and when I plug it in, it tells my car that we're plugged in. And then this little device in this box that I did here, and again I'll link to it in the video here. I think it was my part 6 video where I did the charging system. There's a little device called an AVC2. That little device there looks for this proximity pin, and then negotiates a pilot, which is the other pin. That pilot is a little signal that tells the charger, hey, we're plugged in, we're safe, you can go ahead and turn the power on. And once you turn the power on, then it can charge. Well, here's the problem. With Louis' dead 12-volt battery, that little AVC2 module, I don't know if he has that, but he has something similar to that. It runs off, guess what, 12 volts. And when his battery was completely dead, he didn't have the 12 volts.
Didn't have any batteries, the market didn't, but there's a hardware store here, and it does have a sign saying batteries, so... Okay, right, that's the place of battery.
Right, so as you just saw, Louis' fix the next day was to go and buy a brand new battery and install it, and then he was able to get his car charged back up again and back on the road. Let's pause for a second here and talk about some of the lessons we learned from what we just saw. Well, the first lesson, and this has actually nothing to do with the 12 volt, which I'm focusing on in this video, but real quickly, it would be that the state of charge for your main battery pack, if it reaches below 20%, that needs to be a higher priority for you and I, right? And when I say high priority, there are things we can do through automation to make it a more high priority. One example of that, and this is really low tech and I don't recommend it, but years ago when I did my Spitfire, I had a pop box for my throttle. And my BMS, which was a pretty cheap distributed little BMS system, when it reached a below state of charge of 20%, it would do two things. It would sound an alarm in my dashboard, and then simultaneously a little relay would kick in and it would introduce a resistor in line to my throttle pedal. What that ended up doing is making the throttle extremely soft, and it made it really difficult to accelerate. Now, I don't recommend those because that was extremely irritating after I experienced that a few times. But in today's world, there are controllers that have features built into them, like economy mode or emergency mode type settings that your BMS or maybe a programmable state of charge gauge like a JLD 404 could switch on when you reach a state of charge below 20%. Those would accomplish kind of the same purposes within the controller to limit your throttle, your acceleration, or your motor current. Well, the second lesson, well, it's not really even a lesson, it's more of a confirmation of my design here around the DC to DC converter and the battery. It's a very common in the EV conversion space to run your DC to DC converter always on, meaning always connected to the main battery pack, and maybe you not even have a backup accessory battery. And that's valid, right? But that's probably more valid in the case that you have a well-built and overbuilt battery pack, for one, such that going below a state of charge of 20% might be very rare. And then on top of that, having really fine-tuned your BMS and your state of charge, detection and all that kind of stuff. Now, in lieu of that, I think it's a better idea for my situation and for Louis to run it like this, where the DC-DC converter is switched on and off and you have that accessory battery. In the case of Louis, he actually broke down, but he shouldn't have broken down with this methodology that he has. A little bit of a spoiler alert, later on in the video, like a week or so later, he actually experiences the same drain on his 12-volt battery, on his brand new one. And he realizes that the root cause wasn't actually the battery just suddenly went bad, his original one. The root cause was he had some sort of battery terminal issue or battery cable issue that was preventing the battery from charging while the car was on, and it was intermittent. Once he fixed that, that pretty much fixed the problem. Now, in the case of where he broke down, he wouldn't have broken down if he had that battery cable issue right, because what would have happened was his DC to DC converter would have dropped out, and then his battery would have kept him up for enough time to get him to where he wanted to go. Now, he still would have gotten to his destination by the skin of his teeth, but he never would have completely lost power and broke down on the side of the road. Had he run only a DC to DC converter, he would have had the exact same outcome. The other reason I would never just run a DC to DC converter always on is because I, like Louis, will have to store this car for maybe months at a time. Now, the reason for me to store is different because I live up in the north and I'm restoring this car and I don't want to see it rust out during the winter. It's not because I can't solution battery and cabin heating, but I don't want it to rust out. I put a lot of work into this car. So in the winter time, imagine if you're running the situation where you had a DC to DC converter, no accessory battery, but that DC converter is always on, and you're sitting the car for months at a time. Really, what has to function in the car while it's off is really just your battery management system, which typically runs off 12 volts, the head module that's keeping things, monitoring your main pack, and the little AVC2 or whatever your module that deals with your charging stuff. Now those typically run low current, and they can, any kind of, especially Louis' 66 kilowatt battery pack can probably keep those up for many months. That's not the problem. The problem is what you don't know. If you had a parasitic load you weren't aware of, or even worse, a short, you could actually drain your main battery pack down and potentially damage it permanently without your knowing when storing the car. Now in my situation, the worst case scenario is I would drain down my 12 volt, my accessory battery. That's not as big of a deal. Now, you might think, well, as long as you don't have a parasitic, something you didn't know, like a parasitic drain or a short, the 12 volt battery would most assuredly probably not be able to hold the BMS for many months. But I've solved that problem too. Let me show you that. I mentioned before I have a video in my EV conversion playlist just on the charging system. I think I said it was part 6. It's actually part 7. This goes back to that again. I talk about this there. As you know, of course, I have my charging system set up, which has my onboard charger that's in here for my main pack. But I also have another onboard charger, and that's actually in my DC command center here, and it is a 12 volt lead acid battery charger and maintainer. And I'll have a link to it in the description so you could purchase this. It was only about $35. So what I did with this device is I actually wired it into the charging box into the AC power, because this is just a normal thing that you plug into the wall. So I wired it into my charging box here, which is where my AC power goes into to feed my onboard main pack charger. So the good thing about this is it can charge and maintain my 12 volt battery indefinitely. In the winter time, what I can do is make sure my main pack is at a good state of charge with my charger, and then what I can do is turn off my main pack disconnect switch. That'll keep my main battery pack from charging, but it'll also keep it from discharging. This right here is my shut-off switch for my accessory battery. I will leave that on so that the AVC2 can keep the charging, the pilot signal on the charger going, so that I have voltage coming in. But the only thing I will need that voltage for is for this charger maintainer. And it's a smart charger, so it knows when the lead acid battery is at a full charge to just leave it alone and only charge it when it needs that maintenance charge. That'll mean that if I have a BMS system that draws a bit of current, or anything else that needs to be alive during that storage time, I can be confident that it will stay up and running and I won't have any issues with either my 12 volt battery or my main battery pack. Now, after Louis' incident that day, he actually learned a lesson himself, and I'll let him speak to that right now, and then I'll tell you how I resolved that for us.
Making a spontaneous little stop off at this huge service station. What I'm looking for is a little cigarette lighter USB plug, but it has a voltage readout to tell me what the voltage of my 12 volt battery is. What it means is I can tell whether that 12 volt battery is still being charged or whether a fuse is blown or something, because that was the issue I had yesterday. Yeah, yesterday.
It's one of these, but it has a voltage readout on it. Oh, no, not that one.
I might need to order one to pick up from somewhere. I guess for the meanwhile, if I can check the voltage of the battery with the ignition on to check it's charging. Didn't find what I was looking for.
What Louis was looking for was something like this. Now, actually, he was looking for one that could plug into the cigarette lighter. I hate cigarette lighters, and I hate everything that plugs into them. So the first thing I did on mine was I just bought a brand new marine-style phone charger. It's got a USB-C and a USB port for charging my phone, and it has a digital readout so that I know what the state of charge is on my 12 volt system here. This is what he should have had installed in his dashboard. Now, here's the thing. This will not tell you while you're driving, while I have my key on, what my battery voltage is. So I wouldn't know necessarily that my battery is drained down. But what I did was, just like the cigarette lighter socket, I believe I wired this thing onto my constant power, as you can see, because my key is off right now. When the key is off, this is measuring and telling me exactly what my battery is, which is 13.1 volts. So it's fully charged pretty much. Now, once I turn my key on, this should jump up because now it's going to reflect the system voltage, which is the DC to DC converter. Why this helps is because, like I said, when the key switch is off, I know what the battery is. When the key switch is on, I know what my DC to converter is doing. While I'm running the car, all I'll see is basically the DC to DC converter. But it does give me an idea, right? Because the DC converter should put out a voltage of 13.5 to 14 volts. Whereas typically the battery will have a 12.5 to 13 volt range. So I'll know from running that if I'm not at a 13.5 to 14 volts while my car is on, something's wrong with the DC converter or some load is really pulling hard on it. When the key switch is off, if it's below 12 volts, then I know there's a problem with the battery. This would have been invaluable if Louis would have not only had this, but he checked it at various intervals when he stopped to eat or whatever. He would have known that his battery wasn't charging anymore. Do you hear that sound? That was the sound of my brake vacuum booster pump. That's responsible for making sure I have enough vacuum in my brake booster, and it runs off that electric pump back there. The other thing I highly recommend is having a vacuum pressure gauge. You don't necessarily need it in your dashboard, but somewhere where you can monitor it. And in this case, you're monitoring if it's fully pumped up and maybe you come back to it in an hour and it lost some pressure, that's bad. That means you have a real bad leak in the system. Now, over several days, if it loses the vacuum, maybe that's all right. As well, I also have another 12-volt battery gauge connected. Again, this is only when the key switch is on, so this is pretty much useless. But, you know, because I had those pair of gauges and I had that double bracket, it looked a lot better just having them both in there. But that's the important thing that he learned there is visibility of your state of charge on your main battery pack, state of charge on your vacuum, and state of charge on your 12-volt battery. All equally important. Now that I've given you my opinion on including an accessory battery in your EV conversion, let's talk about battery type options. This is not something I'm an expert in, but I will give you my thoughts and opinions on this, and you can decide the best option for you. Now, obviously, I went with the simplest option, which is to buy a standard car starter battery. These are typically measured in CCAs or cold cranking amps with a secondary number called reserve capacity. The CCA is pretty meaningless for our purposes because EVs don't have a starter motor, so just look for a battery that has the highest reserve capacity that fits the group size of your car. The reserve capacity refers to the number, typically in minutes, that the battery can keep up a 25 amp load before going below 10.5 volts. Now, the reason this is the simplest option to implement is just simply because these are made to fit your car. They're cheap, they're designed to be charged by the alternator, so they're happy to be paired with the DC to DC converter. So it's pretty much the simplest option to implement. Notice that I put that one of the cons is the lifespan. Now, my experience has shown that with these batteries, they last about half as long in an EV as they do in a gasoline engine car. So like maybe 3 years instead of 6 to 7 years. And you would think that this battery would last longer in an EV because it doesn't give it the punishment of having to operate a starter motor. But it's in fact the opposite. That hard inrush current from the starter motor actually aids in the desulfonating of the lead plates, which increases the battery's usable lifespan in a gasoline engine car. Now, the next one is the marine or deep cycle battery. Marine batteries are kind of a hybrid between a deep cycle battery and a starter battery, but more leaning toward the deep cycle battery since boats don't require that much current to get started. Now, these are typically measured in amp hours or reserve time. And in my opinion, they're a little better for EV purposes than a starter battery, but they're less commonly used because they are even bigger and bulkier. And a lot of times these flooded deep cycle batteries require maintenance. So these are not as commonly used in an electric vehicle. Now, the next option, and probably, in my opinion, the best option for an EV conversion, is a sealed lead acid battery like a gel or AGM battery. These are smaller and they're focused on amp hours for deep cycling. And these have been used in production EV cars like the Nissan Leaf and many of the Tesla models for this reason, being small and focused on that amp hour capacity. Now, one question I have, notice I put in the cons the charging algorithm. I'm not quite sure about this. One question I have is how well do they handle DC to DC charging? I've seen conflicting advice on the internet. Some people say, no, they're fine to be hooked directly up to an alternator or a DC to DC converter. But others will say, no, they insist on charging them with a smart charger, like the charger maintainer that I showed you earlier in my car. A lot of times these are people from the solar industry because a solar charge controller is very similar to a DC to DC converter, and many people that have AGM batteries as solar storage batteries will insist on putting that in between the charge controller and the batteries themselves. Now, I may upgrade to one of these once I have more clarity on this answer, but we'll see. And finally, the next one is lithium. Now, this battery that you see here actually kind of looks like a motorcycle or ATV starting battery, but it's actually a 12-volt lithium pack that's used in the newer Tesla Model 3s as the accessory battery. Now, you guys know the pros and cons of lithium. But again, the biggest problem, like possibly in the AGM, is that these are not well suited to connect directly to the DC to DC converter. So these are more complicated to use. Now, my guess is to implement one of these, you would have to have a high current relay and a separate DC to DC smart charger to implement something like this. So just to illustrate this, for example, if you have a high current single pole double throw relay, like a 12-volt relay, like the one in the picture here, and your battery's wired to the normally closed terminal of that, when your DC to DC converter is turned on from the key switch, this relay could be powered to open or disconnect the battery from the circuit such that it never touches the DC to DC converter. In other words, so when one is on, the other is off. Now, during the running of the car, when the battery is disconnected from the circuit, you still want it to get charged. So what you could use is this DC to DC smart charger here. Again, this is from Renogy, and it's common in the solar industry, like I said, to put in between like a 12 or 24 volt solar controller and the batteries or storage batteries. And so you could use a DC to DC smart charger like this, powered from your DC to DC converter, to charge the battery while the car is running. Again, I'm just spitballing here, so don't take any of these products or solutions as gospel. Like I said, in the future, if I upgrade my battery to either an AGM or lithium, I'll implement something like this, and then I'll be more ready to show you the complete solution. Well, that's about it for this video on 12-volt battery options and issues that you could have in an EV conversion. If any of the products you're interested in are in my video description, please click on those Amazon links that are in the description there. That helps me out because that link has my built-in affiliate ID. And if you go to Amazon to buy any kind of products, if you click on that, I get a little commission just referring you to Amazon. So I'd appreciate that. Also, you can help me out by liking my videos or subscribing to my channel or leaving a comment, and that would be great. Thank you so much for staying till the end, and we'll see you on the next one.